I want you to picture this situation. And then I want you to tell me what is the pressure in newtons on every rope you see. In order to solve this type of question, the first thing we will have to do is graph it. So it's easier for us to understand. This step is very easy. We just have to draw the physical ropes in the form of a calculus graph. And mark the forces that we know about. Let's focus on T2 and T3, since they are the unknown variables to us. The object we have is at rest since it's hanging by the help of the rope, so the statement sigma F checks out. I'm using trigonometry to analyze T2 for x and y factors. Please note this will not output the final value since we don't have enough data, but we will have to multiply it by T2 once we find its value. Use cosine to find the Tx value, and sin to find the t value. As you see, the value of T2x is 0.906 multiplied by T2. Now let's use the function sin to find the T2y value. The T2y value is equal to 0.422 multiplied by T2. Now let's do the same for T3 using trigonometry. As we mentioned before, use cosine in order to find the x value of T3. The same thing applies on the value of y for T3, but this time we shall use sine. If you don't understand why, I recommend to take a course about trigonometry. I'll see if I can include a link in the description. How wonderful! Our graph now includes a bit more data, but in order to calculate the pressure on each rope, we will have to find the value of T2 and T3. Like we mentioned before, we know that the object is at rest, which according to Newton's first law, its net force should equal 0. And also we know that T1 is equal to -30, so that must mean that T3 plus T2 is equal to 30. Sigma Fx is equal to 0, so we can use T2x and Tx to build up an equation that equals to 0. This can help us to break the variables to a single variable so we can make up an equation for sigma F. As you see, T2 is same as 0.511 T3. The following equation can help us to find the value of T3. Now I'm just putting the numbers in blue into the equation, but if you pay deeper attention you can see that I replaced the T2 with 0.511 T3 in order to break the equation into one variable and make it solvable. And finally this is the value of T3. So now all we have to do is find the value of T2. We can do that, but first let's find the y and x values for T3. You have to multiply the values by 26.5. I did that already behind the scenes. Here are the results. And lastly, making two equations for sigma Fy and sigma Fx. Use the Pythagorean theorem to find the hypotenuse, which is 15.01. That's it, we are finished. We found the approximate pressure value on each rope. Thank you all for watching and goodbye.